All right, continue to the second half. The second half will be, we'll finish off this chapter here, and then we'll probably be able to touch on some of the continuous random variables, but we'll see. Because when it starts complex familiar on the revision chapter, it's hard.
Yeah.
Right, it's hard. All right, next one will be question 16. So guys, note that whatever questions that I've gone through today, you have to be comfortable with all of these next week. So next week I'll consider doing a spot check on these questions. Pick a few. If you can't do it, haven't been studying enough. Okay. I will go through a lot of questions, but I'll only pick a few for next week. Spot check. Okay. 16. A binomial distribution with parameters n and p has mean 6 and variance 3.6. When you see binomial distribution, what's the formula for mean and variance?
The EX one?
No. Wrong guess. EX1 is for continuous distribution.
Oh, NP. What is it? NP and NP, and then the other one's NP brackets 1 minus P?
Yeah, that's right. Okay, so we've got NP equals 6 and NP1 minus P equals 3.6. Find the values of N and P. Well, simultaneous equation. Okay, that's equation 1, that's equation 2. I go equation 2, divide equation 1. Okay, so I've got 1 minus P divided by P because the N is gone equals to 3.6 divided by 6. Once again, to work out this thing algebraically, just take 36 divided by 6 is 6, right? But put back 1 decimal place, so that will be 0.6. Okay, just do a revision for whole numbers and put back the decimal places after. It's not too bad. Okay, then bring the P over there, so that'll be 0.6P. Then add 1 to the other side, 1 equals 1.6P. So P would be 1 over 1.6. Oh, actually, I'll write it this way. 1 over 1.6 equals P. And note that you need to convert that to a form that is easier to work with. So first, you times top bottom by 10. So P, I'll rewrite, P equals to 10 over 16 and simplify that. That will be 5 over 8. Yep, that's the simplest one. Okay, so NP equals to 6. So N times that equals to 6, which means N would be divide by 5, so it will be 6 divided by 5 over 8. Now when you divide a fraction, you times by the reciprocal. Can we simplify anything? No, doesn't look like it. 8 and 5, 6 and 5, no. So just times it together, so it'll be 48 over 5. Okay, so that would be 4.8. Yeah, seems a bit strange, right? 48 over 5. Looks about it. Looks like it. 10, 5 over 8, yeah, 1.6. Yeah, it's a strange variance. Wait. Yeah, it's a strange variance. But
Can you do 2 divided by 1 on that one, because only one NP is being times in there. The other one's just plus or minus, isn't it?
Sorry, what was it?
Like that first step where you get 2 divided by 1.
Can
you do that? Because only one NP is being times into it. Doesn't this cancel straight away?
Oh yeah, you're right. That's right. Okay, yeah, I think I skipped too many steps. Okay, let's write it properly. It will be like that. So then yes, it will actually cancel off like so. Yeah, sorry. So there's just 1 minus P equals 0.6. Yeah, that makes more sense. Yeah, P, yeah, otherwise P is a bit strange. Okay, so yeah, move that over. So P would just be 0.4. Okay, that looks a bit better. Yeah, that's right. Doing too many questions. I'm slowly losing my mind here. So 0.4, that will be 4 over 10, right, which is 2 over 5. Okay, and then N times P equals to 6. So N times by 2 over 5 equals 6. Okay, that's better. So N is not a weird fractional number. So N would be 6 divided by 2 on 5, which is times by 5 on 2. Alright, that'll be 30 divided by 2 is 15. Alright, that's better. 0.4 and 15. N and P. Alright, so again, just simultaneous equation. It's not too difficult. 17, the second complex familiar for today. Let's see how hard this is. I think most of these complex familiar ones probably have to work through it in here. A factor is rolled 3 times. What is a probability that a 6 is obtained on all 3 rows? Oh, actually, yeah, actually it's not too bad. It's not too bad for question A. All 3 means the probability, so let x be the number of 6s. So you gotta define your variable first, number of 6s. So x is a binomial distribution, right? So probability that the number of 6s is equals to 3 on all 3 rows. And again, it's the chance of success times raised to the power 3. Yeah. Okay, I think 6 by 6 is 36 times 6 is 216, so that'll be 1 over 216. Okay, now question B is a tricky one. At least 2. So probability that x is at least 2. Right, out of the 3. What does that mean then?
Do you have to draw a table out, or it's like 1, 2, 3?
You can, but you don't need to work out everything. Okay. At least 2 means anything that's more than 2, and the maximum is 3. So that will be the same as x equals 2 plus PR x equals 3.
So you just find 2 and then add it.
You just gotta find 2 and you add it to 3. So find PR x equals to 2, it will be chance of success raised to the power 2 and chance of failure 5 on 6 raised to the power 1, right? And then the first one would be 3 choose 2. So again, once you get to that point, you gotta use the table here. So 3 choose 2, so that's 3 0, 3 1, 3 2 is this one here, right? That's 3 choose 2. So that would just be 3 times.
Yeah.
Okay, and then you plus what we found earlier, 1 over 126. Now note that on this left hand side here, it would just be 6 squared times 6, which is the same denominator. Yeah. Right? So that'll be over 216, and in the top it's just 3 times 5, which is 15, plus 1 over 216 is 16 over 216. When I see this number here, so note that the bottom was 6 times, right? So let's see, 6 times 6 times 6, 2, 2, 3. Okay, the last 2 digits are divisible by 8, which means I can divide that by 8. Divide the top by 8, I get 2. Divide the bottom by 8, I get 2. And then 56 is 7, 2 over 27. Okay? Yeah. Yeah, so that's that. Next is question 18. So this first one is not too bad. Okay, the next one is the expression one. So this is the pure theory. There's no number in here. Let P be the probability that a random chosen belief, blah, blah, blah. That's the probability of success. 8 people are asked, n equals 8. Okay, and P is the probability of success. Write an expression for the probability that all 8 believe in ghosts. It would be P to the power 8. Yeah. Right, because all 8. B, none of the 8 believe in ghosts. It would just be 1 minus P to the power 8. Yeah. Right? At least 1. So probability that at least 1, right, is the same as what? Is there an easier way to do this?
The probability of 8 minus 1 person?
No, at least 1 person. So technically this is the same as PR x equals 1 plus PR x equals 2, and then so on and so forth, plus PR x equals 8. Now the question is there an easier way to write this?
Probably.
Yeah. What are the numbers? 0, 1, 2, 3, 4, 5, 6, 7, 8. You want 1 onwards. It's the same as 1 minus
1 minus 0.
1 minus the probability of x equals to 0. Right? Because this is the box, right? The whole box has the total probability of 1. And if you want 1 forward, the total area is total area of the box equals to 1. So if you want the right hand side, it's just 1 minus the left hand side.
Oh, well, yeah.
Yeah?
I did it the other way in my head.
Yeah. So that'll be 1 minus PRX equals to 0, and probably should write this one here. None of the 8. So PRX equals to 0 equals 1 minus P to the power 8. And the first one is PRX equals 8. Okay, so basically 1 minus P to the power 8. That's it.
Yeah.
Okay, so it's conceptually hard, but if you know it, it's not too difficult yet for this one here. Okay. Alright, let's see. This one is going to be a bit tricky. X is a binomial random variable, mean 3, variance 2. So express PRX equals 1 in that form where A and C are prime numbers. Yeah, this is a...
This is techie.
Yeah, so this is how they will specify exactly what form they want, and they test you on not just the basic concept, but algebra as well. Mean 3, variance 2, and P equals 3, and P 1 minus P equals 2, right? So when you divide them, 1 minus P equals 2 over 3, so then P is 1 over 3. Okay, NP equals 3, so I'm just going to work through it. Quickly get N equals to 9. So 9 times a half is 3. So I've got N and P. So then PR X equals 1. Okay, AC are prime numbers, mean 3, variance 2. Okay, yeah, so that would be 9, choose 1. Right?
Yeah.
Yeah. 9 choose 1, and that's why this is a tech-free one, because you can only work 9 choose 1. So you need to understand the formula. P power 9, 1 minus P to the power power 8. Sorry, 1 here and 8 here.
Yeah.
Okay, so 9 1 is 9. P is 1/3, so that'll just be 1/3. 1 minus P is 2/3 to the power 8. You see?
Yeah.
If they ask you in this form, A and C are prime numbers, they're asking you for the index laws. Alright, so now you gotta combine them using index laws.
Yeah.
That actually will be easier because you don't need to work out what 2 power 8 is. You just need to know the index laws. 9 times 1 over 3 is just 3, right? And then times by, distribute the power in, it will be this, right?
Yeah.
And then 3 top bottom will cancel out, so that'll be 2 power 8 over 3 power 7. That's the final answer. That's a form A and C, which are the basis of prime numbers, and they are raised to some power.
Yeah.
That's it.
Okay.
Okay. So it's not too bad, but conceptually, in order to even know what what to do, it could be a bit tricky. I just skipped quite a lot of steps for this one. That's why it looks a bit shorter. But you gotta try it again by yourself. Then you see that's actually not easy. All these complex numerical questions are not easy. They're all conceptually a bit challenging. Consider binomial random variable x with parameters n equals 20 and p equals 1 over 5. So we've got n and we've got p. Write an expression for prx equals k and prx equals k plus 1. Show that, whatever that is, use this result to find value for k for which prx equals k is the maximum.
Oh my.
Alright, let's work through bit by bit and see how we go. prx equals k. Okay, x equals k need 20, choose k. Alright, and then times 1/5 to the power k, and then times 4/5 to the power k plus 1. 20 minus k.
Yeah, okay, that makes sense.
Right? Okay, let's see. PR of x equals k plus 1 would be 20, choose k plus 1. And then 1 over 5 to the power k plus 1. And then 4 over 5 to the power 20 minus brackets k plus 1.
It's like specialist, but yeah.
Yeah, kind of. Okay, so yeah, continuing. Now, what's the formula for this? I think it's in the formula sheet. Let me double check to see if you guys need to remember. I'm pretty sure you guys don't need to remember this. Factorial one, combination factorial one. Surely, hang on. Sequence and series. Oh. I think think you need to remember the formula. It's like the quadratics one. They don't give you the quadratics formula. Yeah, so you actually need to know what does it mean by 22k plus 1. I think, let me double check the formula. Even I don't remember that as often. Combination. Normally you don't get that too much. And CR, okay. So NCR is the same as n factorial over n minus r factorial. Oh, sorry, n factorial over r factorial n minus r factorial. Wait, are you guys expected to know this?
That's specialist,
part of
isn't it?
It is specialist. I'm trying to remember if methods in unit 1. I think they were supposed to have gone through this, but it will be weird for you guys to have to memorize this formula though.
Yeah, I remember like a while ago, we did like one lesson on this, on combinations. It was actually one lesson. They just taught us NCR and how to write it.
Okay. Well, if you can remember the formula, do that. If not, you can safely skip question B.
Okay.
Okay, so let's say if I were to stop question A at around here, so 20k plus 1, because when they give you a show that question, it's like 1 or 2 marks, in the exam. If you have to skip that, you have to skip that. There's not much else you can do. And then this will be 4 over 5, and then 20 minus k minus 1 is 19 minus k. Okay, so that's the answer for A. Now let's say we were to skip B, or show that. I have no idea how to explain the factorial, the combination formula. That's fine. We do C first. Use this result to find the value of k for which that is a maximum. Okay. So we want to find PR x equals k is a maximum. So okay, let me see. Find the value of k for which PR x equals k is a maximum. So it will be a maximum when let me think. This question is a bit tricky. Normally you would derive it. So PR, so f at okay, alright. I think I've got an idea on how to do this one, but see if you can follow. This one's a bit tricky. Okay, so note that k plus 1 is the number factor. Right? It's 1 after k, and then k is the main one that we're looking at. So if we were to graph it, okay, I'll give you a visualization. So this is what I see. So let's just say this is each value of k, right? So 1, 2, 3 all the way to 1, 2 all the way to, let's say, k minus 1 and then k plus 1.
Yeah. Okay.
So imagine the height of the bar is the probability, right? So the height is the probability that x equals to whatever that value, and these are the possible x values. So you want a value of k, so that it will be the PR x equals k is a maximum. So find the maximum probability. Binomial random variable. Yeah, okay. Because it will be, so remember the binomial distribution, like the probability will, when you list it out, it will be like a set of bar graph where there'll be a highest one and then it will start decreasing, right? And the highest one is the one that is closest to the expected probability.
Yeah.
Right, remember that? The expected value. So in order to find that one there, we need to find the one where the one before that is lower and the one after is also lower.
Yeah.
Right? Which means that we need to find the k value, need k where PR x, okay? PR x equals k must be more than PR x equals k plus 1.
Yeah, okay.
Right? And also PR x equals k is also more than PR of x equals k minus 1.
Yeah, okay.
Right? It has to be higher.
Yeah.
Or hang on, let's see. It would decrease. No, actually you don't need this one, because if the second one is higher, oh no, yeah, you do need that one. Yeah. So the one before is lower and the one after is also lower. Yeah.
Yeah.
Now if I divide both of this by, let's see. Oh, actually the first one I will divide both sides by PR x equals K. Why? See the formula is K plus 1 on top and K at the bottom. Right? So divide by PR x equals K to get that formula there. Right? Which means that 1 must be more than K plus 1. Yeah, more than this. PR x equals K plus 1 over PR x equals to K. Right? Which means this thing must be less than 1. Okay, you flip it around, you also flip around the symbol, so that will be less than 1. Okay, so PR of x equals K plus 1 over PR x equals K, so this thing must be less than 1. Right?
Yeah.
And then we substitute the formula. So I'll move this thing, the second condition, over here. So substitute the formula in, I would get 20 minus K. Okay, and then 4 times K plus 1 must be less than 1. Okay, because K is a positive number, I'll times both sides by the bottom here. I'll move the bottom over to the other side. I'll get 20 minus K less than 4 times K plus 1. Expand the brackets. 20 minus K is less than 4K plus 4. Move terms around. Move the 4 over the left hand side. It will be 16. Move the minus K to the right hand side. Again, we're moving terms, so we're not changing the symbol. You only change the symbol when you divide by a negative number.
Yeah.
Right, which is taking this and you move it across to the other side. It changes the sign to a positive. So 5K. Then 16 over 5 must be less than K. Again, we're dividing by positive, so you don't need to change the thingy. So let's write it this way. 16 over 5 less than K. That's the first condition. Alright. Now, to get this one here, you need K and K minus 1. So if this is for K plus 1 over K, you need to be able to get the K minus 1 for version of this one.
Yeah.
Okay, so we're replacing K with K minus 1. Alright, so I'll use this one, I'll work this through right here. So given this one, right, then PR, if you replace K by K minus 1, then that'll be K minus 1 plus 1, and the bottom will be K minus 1.
Yeah.
Alright, we substitute K by K minus 1. So PR of X equals K over PR of X equals K minus 1 would be 20 minus, and then we replace K with K minus 1, right? And that'll be 4 times K minus 1 plus 1.
Yeah.
Okay, so that's how I came up with this little formula here. Let's move it. Oh, whoops. Actually, it's okay. So yeah, so I've got that one there, and then continue solving for that. I would get 20 minus K plus 1 over 4K. Right, so that'll be 19 minus K over 4K. And note that this is equals to PRX equals K over PRX equals K minus 1. So we need this one on top, so we divide both sides by PRX equals K minus 1.
Yeah.
Okay, so then I've got this one which is linked to the formula here. So that'll be 19 minus K over 4K. 19 minus K over 4K is more than 1. Alright, times the K to the other side. Standard from the last part is more than 4K. So 19 is more than 5K. So 19 over 5 must be more than K. So flip that around. K is less than 19 over 5. Yeah. Alright, combine this with that. Gets you 16 over 5 less than K less than 19 over 5. Now what are these numbers as decimals? Times that by 2 is 3.2 less than K less than 3.8. Let me see again. Question K is Hang on, give me a second. Let me check with the actual textbook answer first to see if I made a mistake somewhere. These questions are really, really tricky. Answers, chapter 19. This is question what?
20.
20?
Yeah.
Okay, 20 is 4. K is 4. Okay. So one of these numbers is wrong. Which one is it? I think the number that's wrong is probably this one here. All right, let's see where the mistake was made. 4k, 5k, the over 5 is 3.8. You know, x equals k, 20 plus 1. Oh, my bad. 20 plus 1 is 21. Why did I write 19? I think I did minus 1 in my head. Yeah, so it's 21 minus k. Sorry, it's 21 minus k. So this is 21 minus k. 21 equals 5k. Okay, that's better. 21. So that will be 21 over 5. That will be 4.2. There. Okay, now that's better. So k is between 3.2 and 4.2, and because k is a whole number, therefore k equals 4. Okay. So given this, we know that probability that x equals to 4 will be more than the probability of 1 less than that, x equals 3, or 4 minus 1, right? And similarly, probability x equals to 4 is also more than the probability after that. Yeah, so that's the meaning of this question here, right? So this is the main concept that allowed us to be able to do this question. So this one is definitely a complex one. Still have another question B?
Tricky.
It's tricky. Still have another question B? I'll attempt to go through question B for you guys. So PR. So question B, right? Left hand side equals to PR x equals k plus 1 over PR x equals k. And remember the k plus 1 was I think 20 k plus 1. Right, 20 choose k plus 1, and then probability was 1/5. Yeah, 1/5. 1/5 to the power k plus 1, and then 4/5 to the power 20 minus k plus 1. So that'll be 19 minus k. And then we need to divide by, okay, divide by 20, choose k. And then this one will be 1 over 5 to the power k, 4 over 5 to the power 20. Actually, maybe I'll write it as 20 minus k plus 1. And over 20 minus k, like so. Okay? Yeah?
Yeah.
All right, let's work this one out as a very big fraction. So 20 over k plus 1, again, the formula NCR is n factorial over r factorial, n minus r factorial. All right. So n factorial is 20. So the top one, the big one would be 20 factorial, okay, over k plus 1 factorial, and then 20 minus k plus 1, everything factorial. Okay, and then the bottom would be 20 factorial over k factorial, and then 20 minus k factorial. We'll work through that a bit later. But then the next two will be these two here. So if you bring the bottom up, right, that'll be 1 over 5 to the power negative k when you bring this one to the top. So it's just subtract, this is the top power, subtract the bottom power. Yeah. Right, so that'll be 1/5, and then top power, subtract bottom power, which is just power 1. Yeah. Okay, same thing here, that would be top power, subtract bottom power. So that'll be 4/5. Alright, and then top power is 20 minus, open the brackets, minus k minus 1, and then minus 20 plus k. Yeah. Alright, because we have to flip the sign of this one. You're subtracting. Cancel, 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 cancel. That's power minus 1. Okay, so that'll just be 4 over 5, power minus 1. Which means that if we bring this to the bottom, it turns the power into positive.
Yeah.
Okay, or actually maybe instead of doing that, I'll flip this around. So if I flip this into 5 over 4, then the power is positive 1.
Yeah.
Right? Because negative power just means the reciprocal.
Yeah.
And then when you times it, these two will be cancelled out, so that will be 1 over 4. And then we need to deal with this factorial. So let's rewrite the factorial. The top one, to save some time, I'm just gonna copy this. Alright, so that will be this top one. Now, instead of writing it as divide by the bottom, I will write it as multiply by the reciprocal of the bottom. Right? Over 20 factorial. Ah, convenient. Cancel, cancel. Okay? Alright. A little bit tricky, but I think we can still do this one. So the next one would be times by 1 over 4. Alright? Slowly getting there. So now the top is k factorial. I'll combine that first, right? 20 minus k factorial, and the bottom is k plus 1 factorial. And then these two will be a little bit tricky. 20 minus k plus 1, and then factorial. And then everything is just times 1 over 4. So at this stage, you need to understand what the factorial symbol means. So k, let's say factorial. Factorial. Alright, let's say 3 factorial is 1 times 2 times 3. Okay, so 4 factorial is 1 times 2 times 3 times 4. Okay, which means that so note that 4 is 3 plus 1, right? Factorial. Okay, so that's why if we have 3 factorial over 3 plus 1 factorial, right, then you would get 1 times 2 times 3 divided by that. Which means every single factor on top will get cancelled out, and the one that's left behind is the 3 plus 1 at the bottom, and the top is just 1.
Yeah.
Okay, which means that if you have k factorial over k plus 1 factorial, this one, the top would be 1 times 2 times all the way to k. And then the bottom is 1 times 2 times all the way times k, but also times by k plus 1. So every single factor on the top cancel, cancel, and then all the way up to k get cancelled out.
Yeah.
Okay.
It's 1 over k plus 1.
It's 1 over k plus 1. Right? So that's the first part there, and that would be 1 over k plus 1 times by, now we're going to work out this thing here. Okay. So 20 minus k factorial. So now I'll use the notation straight away. 20 minus k, everything factorial, over 20 minus up to k plus 1. Right? Factorial. Alright, 20 minus k. Okay, so that means that you go from 20 minus k, you go from 1 times 2 times all the way to 20 minus k. Right? And then the bottom, now the bottom is a bit harder to figure it out. So put it this way, you go from 1 to 2. Now k plus 1 is always more than k. Right? Which means the bottom will end first with 20 minus k plus 1. Right? And then the top actually will expand that, will have a factor before that, which is 20 minus k plus 1. Because that's the factor before 20 minus k.
Yeah.
It may feel a bit strange, but let's just say, so example, k equals 3. Right? So then 20 minus 3 equals 17. And then 20 minus 3 plus 1, which is 4, is 60. So the bottom number is lower than the top. Yeah. Right? So let's say 20 minus 3 factorial is 1 times 2 times all the way to 16, but then also times 17. And then 20 minus 3 plus 1 factorial is 1 times 2 times all the way to only 60.
Yeah.
Okay, so the top has 1 extra. And the 1 extra is the 20 minus 3. Alright, so that's why when in doubt with the factorial thing, just use an example. So therefore, that would be equivalent to everything will cancel off. Right? So 1, 1, 2, 2, and 20 minus that, 20 minus that. Then the answer would just be 20 minus k over 1.
Yeah.
Okay? And then we bring this back into the result here. That will be 20 minus k over 1 times 1 over 4. Okay? Which is 20 minus k over 4 times k plus 1. Alright? 20 minus k over 4 times k plus 1 is this thing here.
Holy. Yeah.
Okay, so this question requires you to first know the formula and second know how to work with factorials. I don't think it will be an exam, it will be a bit mean to do that. Not for the internal, external maybe. If you're unlucky, you might get this one. Okay, it goes to the right hand side, which is shown.
Yeah.
Okay, so this probably is the sweatiest one in terms of algebra up to this point. Alright, so you gotta be able to do everything else first and maybe you can tackle this. This is like a 3-page question. Okay, will be a lot of questions. It's good for algebra practice. Okay, the only thing that you guys may choose to skip, if you want to skip it, that's okay, you can skip it. I will not quiz you on this question B. If I were to do question 220, I'll just be, given this, use the result to find PR of x equals k is the maximum, because this question is still technically part of unit 4. You need to understand the binomial distribution and the probability distribution of the binomial distribution. And if you know that, then you can somewhat figure out question C. So C is a fair complex familiar. B is not really. B is like what? Why would you ask this kind of question to a math method student?
Do you reckon that could be like a complex unfamiliar if they say given that blah 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 NTP equals that formula?
Yes.
Oh.
So I would rate this one as complex unfamiliar. Yeah. I don't think this is a familiar one.
Yeah.
The PR x equals k is the maximum. That one requires you, remember, to realize two things. Remember, you have to realize two things. Alright? The probability is higher than the one before and higher than the one after at k. So that's the one you need in order to do question C. And B is, if you have time to do it, try it. If not, that's fine. Okay, so that's the hardest one for binomial distribution. Next will be continuous random variable. This one, very, very standard. Okay, this question is actually one of the most standard complex familiar question for continuous random variable. Find k, then find PR, find median, find the mean, conditional probability. This is very standard. In the exam, you won't get all 6. I don't think you ever get a question that asks all 6 of them. But as a revision, this is really good. This question covers a lot of grounds in continuous random variable. Okay, first one. Find the value of k, use total area equals 1. Right? And note the domain is from 0 to 6 only. So therefore, total area is anti-derived from 0 to 6 of this thing. Right, it must be equals 1. You can't anti-derive it straight away until you expand that. So that will be 6kx minus kx squared dx equals 1. And then anti-derive it. Then we would get x squared, so that will be 3kx squared minus k on 3 x cubed 0 to 6 equals 1. Okay? Then we we substitute the values in, sub 6 in, that will be, now note that at this point when I see x squared and x cubed, I don't really want to work it out straight away because I want to take out common factors if I can. So let's see, so 3 times x squared, 3 times 6 squared times k minus 6 cubed times 1/3 times k equals 1. Alright, I'll take out all the common factors first, which is 6 squared times k. Inside would be 3 minus 6 times 1/3. Much easier. Yeah. Right? 6 times 1/3 is 2. 3 minus 2 is 1. So that'll just be 36k equals 1. So k equals 1 over 36. Okay? So when I see big numbers, take out common factors. Use the factorized version. It'll be easier to work with. Yeah. Okay, so that's question A. Find the value of k. We found that. Now question B. PR x less than 4. Very standard, right? Area less than 4 is anti-derived from 0 to 4. Okay? Less than 4 means area to the left of 4, so you anti-derive from 0 to 4 of the main function. Now we know what it is. 1 over 36, and then x, 6 minus x. Again, when you anti-derive with a constant factor, take that out first. So that'll be the same as 1 over 36. Right? Take out the constant factor. So I'm just using this question to revise all the techniques I've told you guys up to this point. Okay, and expand the brackets, 6x minus x squared dx. Yeah. Okay, and then anti-derive, just leave the constant factor out. So 3x minus x cubed over 3, 0 to 4. Okay, and then 1 over 36. Same thing, take out the, when you sub it in, take out a constant factor, which is common factor, which is x. So that will be 4. I'll just save a bit of time. So 3x minus x cubed on 3 is the same as x. And then 3 minus x squared on 3. Okay, I'm using that formula there. So times 4 times by 3 minus 16 on 3.
Yeah.
Okay, and 0 is 0. 4 over 36 is 1 over 9. See, you're already simplifying it, right? You don't need to multiply big numbers in. And inside will be 3, so 3 minus 16, so 3 times 3 is 9 over 3 minus 16 over 3. So that would be, wait, negative? That shouldn't be negative. Hang on, let me see. 6x minus x squared, x cubed over 3. And then, oh, sorry, this will be x squared. Yeah, 3x squared. Yeah, my bad. So you actually take out x squared. So 3x squared. So you take out x squared, that will be 3, and then x over 3. Yeah, there.
Oh, okay, yeah.
Answer will be 4. So times that will be minus x squared and 6x.
Doesn't say it goes to 16 on 30.
Yeah. Yeah, then that won't go over there. Okay. Yep, so that will be 4 squared. And then inside will be 3 minus 4 on 3. Okay. 4 squared is 16 over 36. Or you can just go, that will be 4 over 9, right? So one of the 4 cancels off. So 4 over 9 inside will be 9 minus 4 is 5 on 3.
Okay.
Yeah, so it'll be 9 on 3 minus 4 on 3, which is 5 on 3. So that'll be 20. You can't simplify. So 20 over 27. Okay, that makes more sense. Okay, median. How do you find median? Right, median M is where when you enter the right, right? So the
0.5 equal to 0.5, is that it?
Yes, it's area 0.5 on both sides of median, right? So therefore, you enter the right from the start, which is 0, to the median. The answer must be 0.5. Okay, and the function, we already got that, 1 over 36, and then x, 6 minus x, right? 6 minus x, I think. Yeah. Okay, same thing. This time, or actually to work it out, I'll write it as a fraction and then enter derive it. Again, I already got the result over there, so I'm just going to copy that over. So the result is this thing here. All right, so 3x squared minus x cubed on 3 from 0 to m. Oh, a bit tricky.
Yeah, what?
Is this tech free? This is tech free. Yeah, all right, we'll see. Maybe it's not too bad, we'll see. Okay, so 1 over 2 equals to 1 over 36 of, when you sub m in, it will be 3m squared minus m cubed over 3. Okay, I see now why this is complex familiar. Times both sides by 36, I get 18 equals to 1 times this thing. And it will be out of the brackets now. I'll times 36 to the other side. Like so. Alright?
Yeah.
Times 3 both sides to get rid of the over 3. 54. Move every term to the right hand side because then the m cube is negative, so I want to move it to the other side here. So that'll be m cubed minus 9m squared plus 54 equals to 0. How do we solve this? Non-calculator. Type 3.
9 and 54. Can you even do that?
No, this is a cubic equation.
Oh, it's cubic. Oh, you split it up.
Yes, you need to find a way to split it up, but essentially you need to use the factor theorem. Remember the factor theorem from unit 1? If f of a certain number equals to 0, then x minus 3 is a factor. Right? And then you can do long division.
Yeah.
Okay? So we're going to find a number that makes this thing equals to 0. Let's try m equals to, so when I see 54 here and then a big M times by a negative number, I'm thinking of using M as a potentially negative number, right? Or it could be something that 9 times by M squared would be a really big number. So let's say if M is 2, 9 times 4 is 36, it won't be negative enough, right? So if it's 3 squared is 9, 9 is 81, and 27, yeah, that works. Okay, try and M equals to 3. So you get 3 cubed minus 9 times 3 squared plus 54. So this would be 27 minus 3 squared is 9, 9 by 9 is 81. Yeah, it's subtracting by a big number. So that might get you to 0. Let's see. 27 plus 54 is 81.
Yeah.
Equals to 0. Since let fm okay equals to that, since f of 3 equals to 0, or equals to 3 cubed minus that, it's gonna kind of show that a little bit, right? Which is 27 minus 81 plus 54, which is 0. Then m minus 3 is a factor. Okay, so once you've got the factor, you got to do the long division. M cubed minus 9m squared. If you're missing an m, you got to add plus 0m. See, it's testing the harder questions in unit 1, plus 54, and then m minus 3 here. I'm actually teaching the unit 1 kids like JPC long division, and they have no idea how to do it. They struggle so much. Yeah. So if you can understand long division, you've gone a long way since like 2 years ago. So that would be m squared here, times it down, m cubed minus 3m squared. Do the subtraction, so write it that way. Subtract negative 3 is plus 3, so that's negative 6m squared, plus 0m plus 54. So the next one will be negative 6m, times it back down here, would get me negative 6m squared plus 18m, and then once again I subtract all of that, so that would be minus 18m plus 54, so that should just be 18, or negative 18, minus 18. Alright, so that'll be minus 18m plus 54, which get to 0. Perfect. So then that means that we've got m minus 3 and m squared minus 6m minus 18 must be equals to 0. Okay, then continue solving this. So factors of 18 add up to negative 6 is 2, 9. Okay, again, let's check the, so for this one here, I will go check the determinant first. Determinant would be b squared, which is 36, minus 4 times 1 times negative 18. Yeah, okay, we can minus 4ac. Yeah, we can do this one. So 36, and that will be 4 times negative 18 is plus 72. So determinant is 108. I think the median is just 3. There's only one median. I think the median is just 3. Let's see. Kx 6 minus x is 0 less than x less than 6. Because the other one might be out of range. I will see. So we'll get, based on this one, we get m equals to 3 or m equals to minus b, which is 6, plus minus square root 108 over 2a, which is 2. Right? And then 108, again, if we were to factorize that, it's, let's divide it by 2, so that's 54, divided by 2 is 27, which is 3933. Okay, so that'll be 2 squared times 3 squared times 3, so that will be 6 plus minus 6 square root 3 over 2. Yeah?
Yeah.
So that'll be 3 plus minus 3 root 3. Okay, so now let's have a look. Root 3 is about 1 point something. So 3 square root of 3 is like, this is more than 3. So consider 3 plus 3 root 3. This is more than 6. You can clearly see it's more than 6. Yeah. Right, so reject it. Right, because remember the domain is from 0 to 6. And then the other one, 3 minus 3 square root 3 is less than 0. Also rejected.
Oh, I see.
Okay, so then the only answer, the median is 3. Therefore, median equals 3.
Yeah, that makes sense.
Make sense? Yeah. It's quite a bit of work, but yeah. So that's how you work out median, and then the mean is. I think the rest of it should be okay. You can work out this one, simple algebra. Work out this one.
Yeah.
Right. Just use the formula. I think the median is probably the hardest one. Mean is not too bad. Mean is just times x into it, and you antiderive left to right. Okay. So I'll just write the formula here for question D. The mean, which is mu, would be antiderive from 0 to 6 of 1 over. So you times this x in first, and then that will be 1 over 36 of x times 6 minus x dx. Work this one out, you get your mean. It's not too bad.
Yep.
Just take out the 1 over 36, and then that will be antiderive 0 to 6 of 6x squared minus x cubed dx. Just sub the values in. As I said, once you antiderive it, make sure you use the factorized version, okay? And then you can work through the mean. Okay, for question D, E, and F, it's just conditional probability. All right, so PR x, what was it? So long. Less than 3, less than 2 given less than 3. So PR x less than 2 given x is less than 3. Conditional probability less than 2 and less than 3 means PR x less than 2. Right, because when you add them together, 2, 3, less than that, so they must be less than 2.
Yeah.
Okay, over PR x less than 3. Now, to do E and F, it might be easier to find the big F of x. Okay, big F of x would be antiderive from 0 to x of ft dt. So 1 over 36 t 6 minus t dt. It's just finding the area to the left. Yeah, so that'll be 136, and we already did this calculation before. So 6t, that'll be 3x squared. If you were to work it out, I'm skipping a bunch of steps here. That'll be 3x squared minus x cubed over 3. So that'll be 3x. Yeah, that'll be x squared. Yeah. So yeah, so if you find big F of x, it will be like that, and you can calculate big F. So this is essentially the same as big F of 2 over big F of 3.
Yeah.
Okay, you sub 2 into this big F equation, and then you work it out. Does it make sense? Remember the big F, area from the left all the way to a certain value x?
Yeah.
Yeah, and then we use t instead of x so that we can sub x in and get the answer.
Yeah.
So once you've got the big F notation, you can sub the values in, and then it will be a lot easier to work out these the extra stuff for question E and F.
Okay.
Okay. But yeah, that's about it. So we've got up to question 21. All right, so that's the last question for this lesson here. Next week we'll continue with more.
Okay.
Okay. All right. Make sure you. So Peter, if you're listening to the recording, make sure you redo every single question on the 2 recordings. Okay. So 21 questions from now to next week. That's a goal. Okay. Good luck.